Okay, let's have a quick read. A small smooth ring R of weight 7 newtons is threaded through a light and extensible string. The end of the strings are attached to a fixed points of A and B. The same horizontal level. The horizontal force magnitude 5 is applied at R. Okay, and the string is taut. Okay, in equilibrium position at that angle is a right angle AR. Okay, and the portion of the string attached to B is at that angle. Okay, see diagram. So first of all, it's the same string, so that tension is going to be the same as that tension. It tells you that force here is 5. It tells you the force here is 7. Okay, so anything else we need to know? Horizontal, yeah, everything else is okay. Explain why the tension T is the same in each part. It is the same string. Okay, so that finishes that one off. So it's the same string that has a ring threaded through it, and that ring is smooth. I'm sure it said it's a smooth ring, that weight. Okay, there it is, smooth string, so there's no friction at that ring. By resolving horizontal vertical forces on R, form two simultaneous equations consisting of those, and hence find T. Okay, so what we got here, we've got force going that way, that's being stretched out, and a force going that way. So what I could do is, if I just sort, yeah, let's do it this way. So if I go and put this as a right angle, so this force, this tension here is pulling it upwards and then pulling it that way, and with this one the force is pushing it that way and then pushing it that way. So I'm just trying to work out, so that will be 90 minus theta, that will be 90, so that will be theta in this case. Okay, just to put it there, that's a right angle, that's theta. So what we got, let's look at it from this triangle, this side here. So we got tension pulling it that way, which will be T sine theta, and then it's pulling it that way, which will be T cos theta. So that's T sine theta, and that going that way is T cos theta, which makes up that. Likewise, looking at this one, let's call that theta now. That's going to be going that way and then pulling it that way, this string. So that's going to be going this way by opposite T sine theta, and it's pulling that way by T cos theta. Okay, now we got those. So it goes with two strings. So what we got in the first instance, so if we look at the x components, that's x component. So we got let's say all this, we take this as the positive way, so we got T cos theta. We also got 5 newtons, so those forces are pulling it to the right, and the forces pulling it to the left, the only is this one, minus T sine theta. Now it's held at equilibrium, so that will equal 0. Okay, and the y components, we've got we got T cos theta plus T sine theta, and that's pulling it up. The only thing going down is this 7, so that plus that is going to give me 7. Okay, figure balance. So actually I could put that to the other side. So really, actually if I put minus there and make that equal to 0, what I could do is I could add these together because it gets rid of one of the components. If I add those together, that will give me 2t cos theta. Let's just have a look at this. If I add them together, that will give me t cos theta. They will disappear, and that will give me minus 2 equal to 0. Take that to the side, so t cos theta is going to equal 1. So if I put that 2, put the 2 to the other side, divide by 2, t cos theta equals 1. Okay, so I'll get, so I've got that one, and if I subtract those forces, so if I do y take away that, I will get, they will disappear this time. That minus minus becomes 2t sine theta minus 7, that'll be minus 12 equals 0. Therefore 2t sine theta will equal 12, and t sine theta will equal 6. Now I want to find those, so what I could do now, so in one equation I did x component plus the y component, and in this way I did y component minus the x component to get the t. Now the reason why I did that, because now I can do t sine theta divided by t cos theta, which will be 6 over 1. The t's will cancel, and that will give me tan theta equals 6. So theta will equal tan inverse of 6. If I do that, I'll get tan inverse of 6, which will give me, which is pretty steep, 80.5 degrees. So we've done that one. And if I want to find the tension, I can find it from any one of them. I can just do tension equals 6 divided by sine of 80.5. So let's just do that. So 6 divided by sine of answer, and that's going to give me a tension of 6.08 newtons. Okay, so just be careful when you got those. When I did that, I realized I still got two unknowns. Then I can do it the other way, get the sine, then I can share them by, and I know that the t's will cancel and tan will come out. As soon as I got that, I can cut it back from there. Okay, hope that helps.